Hello, welcome back to Daily LeetCode Live, where I do daily LeetCode questions, raw and uncut. So let's get started. So today's question is product of the last k numbers, right? So what does it want? It wants us to design an algorithm that accepts a stream of integers and retrieves the product of the last k integers of the stream. Right. So that means we can add numbers. We don't have to support remove or anything, but we want to retrieve the product of the last k integers. So did it say largest or like the last k? Well, it says last k. So okay, so I think that means like the most recent k. Let's just see what it actually wants. So this is the constructor. That's the add number function, a method that the class has, and then get product or int k. Right. So k is actually a variable here. Okay. So you can assume that that always the current list has at least k numbers in it. So we don't have to worry about like maybe there are only like 3 numbers, but k is 5 or something. Well, so my first thought is definitely like a prefix sum kind of way of doing it. So like I can use like it would be prefix product. Like that will allow you to get um the last k integers in O1 time, right? Like the product of it. And yeah, and the other thing is when we add another number, so how prefix sum work? Well, here it will be prefix product, but let's say we have like 1, 2, 3, 4 here. How it works is so if we are summing, oh, actually, I'm not sure if prefix product would work, because like I'm just thinking about like what happens when you have a zero. But like what I have in mind is like, so let's say this is the array. The prefix product thing, well, it will be 1, 2, 6, 24. So basically, like the ith element in the prefix product array would store the product of like of item, well, or of the first element all the way up to the ith element. Yeah, but we definitely have to think about like what we do when we see a zero, and like what are the bounds. So so the numbers are quite small. K could get quite large, and we are guaranteed that, well, we are guaranteed that like k is only going to be 40k. And at most 40k calls would be made. So yeah, so that means like because it is still like 40k, we can only do well, either we can only do either like an on solution or n log n solution. Well, it could be like k ok or something. But yeah, so also there's a follow up here as well. So it asks can you implement both get product and add to work in O1 time complexity? Right. I think we can definitely look into prefix product, but we definitely need a way to separate out whenever we see a zero, right? So yeah, so let's do that. So why let me kind of explain why zero wouldn't work first, maybe. So let's say you get a zero here. Well, your running product is going to become zero, and no matter what you have afterwards, well, because like for this entry, we are getting the product of this whole thing, right? And we have a 0 here. So like everything afterwards is going to be 0. So we actually need some ways to like cut ties basically. Like whenever we see a 0. Yeah. So and also like looking at the bounds, we are like the numbers can be from 0 to 100. So so what I actually have in mind is what if we store the latest appearance for 0. So what do I mean by that? What I mean is that when you see a 0, so when you see a 0, yeah, you have to set this to 0, right? But then for the next element after that, we just kind of do a reset. So we'll do 1, 2, 6 here, and we'll mark well, the latest 0 is in this index. And when we are doing the like when we are trying to get product, well, if k is like from 1 to 3, well, yeah, there will be no problem. But what happens when k is 4? So if k is 4 or more, so let's say k is like 6 or something, then well, actually let's do the index here first. So we have 4 here, and we have, how many elements do we have here? We have a total of 8 elements, right? So that means our last element will have an index of 7, and we basically just check whether we ever crosses the latest 0's index. So let me give a more concrete example maybe. So let's say we have so yeah, let's say k is equal to 6 for this case, and our last element is going to be, well, 7, right? And so we can use like the fact, like we know what k is, and we know the index of the last element. We can just use that to find the first element, like the position of the first element of the product that we want, right? So in this case, it will be 3. Or if you like look down here, it will be 6. But what does that mean? Like when we get this index here, well, what is this index? This is 2, right? We compare these two. So if the latest 0 is if it is equal or larger than the index of the furthest number that we want, like from the last k elements, well, then that 0 is going to be inside that like that range of numbers, right? So we return a product of 0. So yeah, actually if we do that, we are going to achieve O1 time for both insertion. So for insertion, so how prefix sum work is you don't recalculate the whole like the whole array. What you do is so like after you have gotten the product of the first 3 elements, well, like after you got the product, so the product here, well, you can just multiply this element to get this range's product, right? So so that means our prefix product is going to be O1, and also to get a product like using this prefix product array, it's still going to be O1 because let me give an example of like what happens when there are no zeros. So let's say I want the last 2 elements. Well, I can just do the product of all 4 divided by the product of the first 2, right? So, well, the product of the first 4 is here, and the product of the first 2 is here. So I just do 24 divided by 2, which is 12. And yeah, that does give me the product of that range. So it's basically just prefix product, but we have to also consider the fact that there could be zeros. So yeah, let's get started. So we have So we have to initialize the things first. So the first thing is we have we need an array. So we need to store the numbers. Well, we are only going to have at most 40k cores. So our array is only going to go like 40k big, and we don't have to worry about dealing with like an array of like millions of numbers in it. So yeah, let's just use a normal array. And then what else do we want? Well, we want to have a prefix product array. So prefix product. And the last thing we want is we want to know the last occurrence of 0. So latest 0 index. Well, we can set it to -1 first. But actually, like, when I was typing this, I'm thinking, like, can we initialize with a dummy at the beginning? Would that make it easier to deal with all the ranges and stuff? And I do think so, because like when we first add the element, we have to consider, because like how prefix product works is it gets the product of the previous term, right? And then it multiplies like with the current number. So yeah, I think like if we initialize the first number to be 0, and also we are guaranteed that k is going to be a valid number. So we don't have to like really keep track of k, and like let's say if k is 3, we are guaranteed that there are at least 3 elements added already. So we will never actually touch the 0 here. But I think that just makes things a bit easier. So yeah, so let's get to add. So first of all, well, what do we want to do? We want to append the number to our nums array. Well, and then we want to multiply, like for prefix product, we want to multiply the previous number, like in the prefix product array, with nums, right? But we also have to consider the case where the last element is 0. Well, if the last element is 0, if the last element is 0, so let's do that first. So if it is equal to 0, well, that means the product is going to be, well, that means like the closest element before inserting the num here is a 0, and we want to do a reset, right? So we can just do self.prefix.prod append. Well, we want to append the number, like every number multiplied, every number by itself. Well, the product is just going to be that number. The other case we have to consider is if we see a 0. So if num equals 0, well, we want to set the latest 0 index. Well, what do we want to set it to be? We want to set it to be the length of the nums array, and we don't need to do -1. So usually we do -1, but we actually added actually, is that true? Yeah, actually, wait, we do need -1. So let's say right now we add a 0 in, we are going to have a length of 2, but then our index, we want it to be 1 here. So yeah, I think we should do this instead. Is there anything else we need to do when adding numbers? I don't think so. If anything comes back in mind, I'll just go back to it. But yeah, right now I think that's all we need. We have appended both nums and prefix product with one number. Oh, of course I'm missing something. So if the prefix product is not 0, we do actually want to multiply with the current number. So when we do this, self.prefix prod the latest element in prefix product. So that will give us the prefix product. Yep. And then we want to get the product now. So first of all, we want to check if length of nums minus k. Well, what did we say before? Like let's look at this, right? If we have 8 elements, we minus 6, we are going to get we're going to get exactly the leftmost element, right? So if that's true, well, we're going to get the leftmost, like the index of the leftmost element. So if this number is smaller or equal to our current latest 0 index, well, just like in this case, well, our latest 0 is 4, but our leftmost index, like in the last k elements range, is smaller, or well, if it is equal, it will be 0. So that means like the 0 is included, and we want to return 0 in this case. And otherwise, well, there are no zeros, so we can just return the like the last. So this will be this case here, right? So if k is equal to 2, we want to actually there are some off by 1 errors. So I think like whenever I see off by 1 errors, I just try to make an example and see whether we have to minus 1 or like we leave it alone or something. So in this case, we actually do want to do a minus 1. So we have the length of nums. Well, this is going to be 4, right? The length of nums. But then we actually want to do this number divided by this number. So if we just do minus k, well, the index that it is pointing at is actually the 6, not the 2 we want. So we do have to do a minus 1 here. So we can just do this, and then divide it by prefix product. I think in Python you can keep going negative to go to the left. Am I sure? Well, actually, if we're going backwards, we can just minus k, because like if you index them, like if you index is minus 1, you get the last element, right? And you want 2 elements down, so you do just minus k in this case. And yeah, hopefully I didn't make any mistakes. Length nums, I think it's self.nums, that's why. Hopefully no more. Oh, integer deficient or modulo by 0. So which test case we got for this one? Well, that means it is touching on 0 at some point. So I think this is the first example. Yes, it is the first example. So the only place we would divide by 0 is probably this here. And for here, the last 4 elements is these 4. So what will we have in our array? Let me think about. So we will have 0, and then, well, the 0 is the initialization that I did there. So it will be something like this. So for our case, k is equal to 4. So k is equal to 4. Let's look at the code. So if the length of self.nums minus k. So our length is 6. Length is 6. Minus k, so that will be 2. Pointing at this is smaller or equal to self latest zero index. So does that mean I did not properly update the zero index here? Maybe that's the case because, well, the latest zero index is 2. But yeah, that just means I didn't update it correctly. Which would be here. Yeah, it will be here. So if the number is 0, if the number is 0, wait, actually, yeah, we should print out. We should print this out if it is run. So let's do this. Well, this should print 0 for this case. It should print 2 for that case. Yeah, so we do get we do actually get 2 there. Maybe the name is wrong. No, that should be correct. That we did see that as well. So yeah, why is it not going here then? Maybe my array is wrong then. Maybe it is not the logic here. Well, actually, we can print this as well and just have a look, I guess. Like, that will also work. Like, there are no more zeros. Yeah, there are no more zeros. Yeah, let's just run this to make sure that, like, it is not the 0 that's actually causing the issue. Actually, this didn't run though. Maybe I do have a... Yeah, this is very strange, but I think it is some off by 1 error, if I have to guess. So let's do that. We should only have one that has the 0 thing. So 4232. That's actually for this one here. Right, that means it is not the latest 0 index that's causing the issue. I think it is the actual prefix product that's causing the issue then. So let's see if we are updating it correctly. So if the previous, maybe we want self nums. So if the yeah, so if the previous number is 0, then we just want to append num. Otherwise, we want to append this, and if it is 0, then it will turn it to 0, so that works. Well, on paper it should work. I'm gonna print out the array to see what is going on. So we can do print self.nums, then we can print self dot prefix product. I also want to print the actual number that we're adding. So let's see where it is going wrong. Right, so we have 0 here. That makes sense. Oh, I think I see I overlooked something. So the arrays are correct. What I overlooked is so remember in this case we have to look like 2 back, right? But when we are checking our when we are checking the, like, for the prefix product, well, what if this is 0? Then this is going to be 0, right? And, well, yeah, even though our range does not have any 0, when we look at this thing here, it does have a 0. So it is an edge case that I overlooked. And we can fix this pretty easily. We can just do max and then 1. Well, because all, like, if there are no zeros, then the minimum is going to be 1, like for the prefix product, right? So I think now it should work. And it does. Well, let's not jinx it. Yeah, it does work. Okay, yep. I think this problem is pretty easy to come up with the idea. There are some, like, a bit of trickier edge cases that you have to deal with. Like some off by 1 error as well. But yeah, again, I think this one is also very doable. So thank you, and I'll see you next time. Bye.